Today we are going to review functions. We talked about functions a little bit in Chapter 1, so now we're coming back to it in Chapter 8. We are going to determine whether relations are functions, and we're going to write functions using function notation. So let's review a couple of things first. What is a relation? A relation is a set of ordered pairs. So for example, I might list a relation like this, with just a few ordered pairs within it. We also need to remember what domain and range are. So domain is the set of all x values or coordinates. This is not the x-axis. That's another reminder. I know we've talked about that before. The x-axis has an unlimited number of numbers upon it. With the domain, I just want to look at a relation like the one above and say, oh yes, I see the domain. We're talking about 2, -5, and 1. If the domain is the set of all x values, the range is the set of all y values. Or again, you could use the word coordinates. And here we are not talking about the y-axis for the same reasons that we don't talk about the x-axis. Okay, so what is a function? Let me get down the formal definition here and then we'll talk about it. So a function is a special relation in which each number of the domain is paired with exactly one member in the range. So it's a special relation, a special set of ordered pairs in which each number of the domain, and we're talking the x values, is paired with exactly one number in the range, y values. So let's go ahead and take a look at another relation and let's determine whether or not it represents a function, if it fits into this definition. So here is my relation. Let's say I have -10, 3, 0, -22. 10, -9, and 20, 3. It's really helpful first to identify your domain and range. So what numbers do we have in the domain? -10, 0, 10, and 20. These are all of the x values of this relation. How about the range? Well, let's see. We have 3, -22, -9, and 3. So let's see what's paired with what. -10 is paired with 3. Okay, it's not paired with anything else. Great. 0 is paired with -22. 0 is not paired with anything else. 10 is paired with -9, and 20 is paired with 3. So as we can see here, each value in the domain is paired with exactly one value in the range. So this is a function. And again, we can say because each number in the domain is paired with exactly one number in the range. Something as a general note to mention, it's okay to have repeated y values, but not repeated x values. And again, we're talking in terms of being a function. So It's still a function if every number in the range is 5. This would still be a function, but you cannot have repeated x values, such as negative 10 paired with 5. That wouldn't work because I would have negative 10 paired with both 3 and 5. So it's okay to have repeated y values, but not repeated x values. Again, when we're talking about functions. There are ways to determine if graphs represent functions without listing every single ordered pair. So if we are taking a look at a graph, such as on page 7, numbers 7 and 8, we can use what is called the vertical line test to decide whether or not what is graphed represents a function. Voila! Here is number 7 that I just recreated, but you can look at your handout. So what is the vertical line test? Well, basically, if we imagine a pencil lying vertically on our graph, we can pass it through all of the points of what is graphed, and as long as these vertical lines only touch the graph once every single time a vertical line is drawn, it is in fact a function. So in the case of number 7, every time I pass a vertical line through one of the graphed points, I'm not actually encountering any other points. So yes, this is a function because it passes the vertical line test. Let's take a look at number 8. So here we have a vertical line actually graphed. Well, this line is made up of a lot of individual points, so let me go ahead and pass my vertical line over all of these points. The question is, do I intersect the graph in more than one point? Obviously, yes, I do. So in this case, a vertical line is not a function because it fails the vertical line test. It doesn't mean we can't graph it. It is still a vertical line. It's just not representative of a function. Okay, so let's go ahead and look at function notation. So let's just see how we can write equations that we've worked with before involving y and x in function notation. So for example, we've worked with equations like these before. These are linear equations. Y equals 2x plus 3. We can create a table of values and figure out when we substitute, a 1 in for x, what do you get for y? And you would get 5, and so on and so forth, and that's how we graphed them. So that's just a review. But how can we rewrite this in function notation? Well, instead of writing y, we can write f of x, and that's how we read that off. F of x equals 2x plus 3. Essentially, it means the same thing as before. We are putting in the number 1 for x, so f of 1 equals 2 times 1 plus 3. And we, in fact, find that when we use 1 for our x value, we get 5 representing f of 1. Y and f of x both represent the dependent variable, which of course makes x the independent variable. You might say, well, why would we write it like this? It's actually very helpful because we can see what exactly we're substituting in for x. So let's take a look at another example. I might give you f of x equaling 4x minus 7. So there's my linear equation, and I would like to know what f of 5 happens to equal. So what does f of 5 equal? Well, it means I have to substitute a 5 in for x. 4 times 5 is 20, 20 minus 7 is 13, so f of 5 equals 13. What if I wanted to know what f of negative 6 happened to equal? I'll do the same thing. 4 times negative 6 minus 7, I will get negative 24 minus 7 or plus negative 7, and that will give me negative 31. I now have two coordinates that I could graph to represent this linear equation on a coordinate plane. So again, I plugged in 5 and got 13. I plugged in -6 and I got -31. Let's take a look at another example. Let's say Mariah spent $22.50 downloading songs to her digital music player from an online music store for 90 cents each. So I'm just going to write down the important information. So she spent $22.50 downloading songs, and they were 90 cents each. That's not too bad. I think iTunes is more right now, $1.29 maybe. So let's see, what do we want to do? Well, let's go ahead and write an equation using function notation. So you want to start by defining a variable like we usually do. So pick a variable, maybe n equals number of songs, because that's what we don't know. We know how much she spent, we know what each song costs, but we don't know how many songs she actually downloaded. So there we go. And how would we figure this out? Well, we are going to start with the total. $22.50 would equal 90 cents times the number of songs she downloaded. We can solve this by dividing each side by 90 cents, and we would get n equaling 25 songs. That just gives us one particular answer to this one situation. However, we want to write a general equation using f of n. In this case, we're using f of n because I'm using the variable n. It turns out that 90 cents times any number of songs will give us our total amount. So if f of n represents the total cost, whatever it might be, I could say that f of n is equal to 0.90n, or just 0.9n. And that is my general equation. Again, what's great about general equations is that we can use them to find other pieces of information. So let's say Mariah downloaded 10 songs. How much did she pay? And this should seem familiar. We've done a lot with direct variation, y equals kx. This particular problem happens to be very similar to that. So let's say she downloaded 10 songs. What did she pay? Well, if n is still my number of songs, let's remember that, I'm just going to substitute 10 in for n, and I can say f of 10 equals 90 cents times 10. We can move the decimal over once, and we can say that if she buys 10 songs, she will in fact pay $9. And you can write that out. If she buys 10 songs, she will pay $9. Let's just do a quick wrap-up because obviously this section has a lot of information. So just in general, we reviewed domain and range relations, and in particular, we used that information to determine whether or not we were presented with functions. Okay, and a function is where every number in the domain is paired with exactly one number in the range. We also looked at the vertical line test. So that's when you have a graph and you're not just given a set of ordered pairs. So if you're looking at a graph, you can pass a vertical line through any point on the graph and you only want to hit the graph once. So vertical line test. We also talked about function notation. So instead of talking about, y equals maybe something like 3x minus 2, we're just going to replace that with f of x equals 3x minus 2. And then we practiced writing that given a certain situation, writing our own general function equation using function notation, and also how we could come up with ordered pairs for that equation. Okay, I will see you in class. Thanks.